Good day. My name is Leona, and today I will be presenting on the 1976 Moro Gulf earthquake. Introduction to the location. The Republic of the Philippines is a southeastern Asian archipelago situated in the Western Pacific Ocean along the Ring of Fire, where many volcanic eruptions and earthquakes occur. The Philippines is comprised of approximately 7,640 islands, and these islands are divided into three main geographical divisions called the National Capital Region. They are the Luzon Group of Islands, which is the largest group and falls in both the north and west, the Visayas Group in the center, and the Mindanao Group, which is the second largest in the south. Hernandez and Gregorio, 2022. The geographic location. The Mindanao Group of Islands are surrounded by multiple seas: Bohol, Philippine, Celebes, Sulu seas, marked by peninsulas, and are said to be heavily divided by two gulfs and the bay: the Davao and Moro Gulfs to the south and the Iligan Bay to the north. Karating, Galanta, and Bocasio, 2014. A gulf is defined by National Geographic as a section of an ocean or sea that extends into the land and often has a narrow mouth. National Geographic, 2019. The Moro Gulf, which is formed from the Celebes Sea, is the largest gulf in the Philippines. It is surrounded by the Zamboangas Peninsula on the west, whose major drainage goes towards the Moro Gulf. Topography. The Moro Gulf has an area of 22,000 kilometers squared, with its deepest section being 5,000 meters and over 40% of it being deeper than 2,000 meters. Alcala, Ingles, and Bukol, 2008. Plate boundaries. The Mindanao Islands, since surrounded by the Philippine Sea, correspond with the Philippine Sea Plate. The borders of the Philippine Sea Plate are all plate convergence zones. It is bordered by the Pacific, Eurasia, Sunda, Oktash, and the Australian plates. The Pacific Plate moves in an easterly direction beneath the Philippine Sea. Meanwhile, the Philippine Sea Plate is moving in a westerly direction beneath the Eurasian Plate. Tectonics of Asia, 2018. The Philippine Sea Plate converges obliquely with the Sunda Plate. It is extremely active and extends from the Luzon in the north to the Celebes in the south. Oktash Plate borders it to the north and the Australian Plate to the south. In addition, transform faults, which are faults where two tectonic plates slide past one another, are present in the Taiwan and Philippine trenches. These faults and the plate convergence zones cause the Philippine Sea Plate to be averaging movement of 80 millimeters per year. Tectonics of Asia, 2018. This increases the possibility of earthquakes, tsunamis, and volcanic activity occurring in that region. Proven by the fact that there have been 7 great earthquakes of magnitudes greater than 8.0 and 250 events of magnitudes greater than 7.0 in that area alone. United States Geological Survey, 2019. The most destructive among this list are the 1923 Kanto earthquake, which had 99,000 casualties, the 1948 Fukui earthquake with 5,100 casualties, the 1995 Kobe earthquake in Japan with 6,400 casualties, and the 1976 Moro Gulf earthquake, which will be the focus of this presentation, with 7,100 casualties. Introduction to the events of the earthquake. Occurring approximately 950 kilometers south of Manila, near the west coast of Mindanao, an earthquake generated in the Moro Gulf. The earthquake was brutal. Arising from the depths of the Moro Gulf, the waves moved in every possible direction, only slowing down as it approached the surface while gradually forming a tsunami. Date and time. According to an article published by the Manila Bulletin and later republished by the website Filipino, at exactly 11 minutes past midnight on Tuesday, the 17th of August, 1976, an earthquake of magnitude between 7.9 and 8.2 on the Richter scale unexpectedly shook those in the area. Filipino, 2022. Persons living on the coastline were given almost no time to prepare. Minutes after the earthquake, tsunami watches were as far as 2 kilometers inland and later followed by 4 9-meter high waves enveloping the 700-kilometer coastline surrounding the Moro Gulf. Filipino 2022. The sudden movements disintegrated the buildings into dust, wood, and steel. The epicenter. The point directly above an earthquake on the Earth's surface, or epicenter, was located at 6.3 degrees north and 124.0 degrees east. It was 40 kilometers off the shores of Sultan Kudarat near the town of Libak and 96.6 kilometers offshore Cotabato City with a magnitude of 7.9. The effects of the earthquake were felt by the islands of Zamboanga del Sur, Maguindano, North Cotabato, South Cotabato, Llano del Norte, Llano del Sur, Sultan Kudarat, and the Basilan, Sulu, and Tawi Tawi. The strongest blow of the tsunami, however, was felt in the Pagadian city, the capital of Zamboanga, which falls in the regional center of the Zamboanga Peninsula. Earthquake shocks. Analysis of seismic records taken before the Moro Gulf earthquake revealed that there were 6 events that occurred with epicenters at 6.3 degrees north, 124.0 degrees east. Philippine Institute of Volcanology and Seismology, 2018. These prior events can be considered as foreshocks. The main earthquake shock was described by the Geophysical Journal as acting with a substantial level of directivity. It was said that the source of separation or rupture broadcasted 160 kilometers unilaterally from the main shock hypocenter and moved in an azimuth of 300 degrees with a rupture velocity of 2.5 kilometers per second. Stewart and Cohn, 1979. The main earthquake shock was followed 12 hours later by a major aftershock of magnitude 6.8, which was said to have resulted from motion in a secondary fault. Stewart and Cohn, 1979. Upon seismic reflection, it was said that sediments east of a trend striking the north-south region of the Moro Gulf were disturbed, resulting in such a major aftershock. Stewart and Cohn, 1979. According to the PAGASA records, there were 40 aftershocks recorded via their seismic network, and on average, 140 aftershocks daily monitored in the Cotabato city. Philippine Institute of Volcanology and Seismology, 2018. Did you know? The gravity of the earthquake and tsunami actually propelled the government of the Philippines to later revise their provision of the National Building Code. The changes made to the code stipulated that all structures should be able to withstand any earthquake of intensity 8. Filipino 2022. We will now move on to the building assessment. When assessing earthquake-affected buildings, it is important to gain a realistic approximation of the behavior of the building's structural system. This means focus should be placed on the building structural system, its seismic vulnerability, the configuration of the building, what materials were used in the building's construction, what the ground conditions were like, and any other pieces of data collected out in the field. Dayala, 2013. For this assessment, we will not be discussing the ground conditions or other field collected data. Structural system. A structural system refers to the structural elements in a building, designed so the members can support and transmit applied loads into the ground without exceeding allowable stresses in the other members. Structural systems can fall into 3 major categories: low-rise, high-rise, and long-span, and various other subcategories. For the purpose of this assessment, we will focus on low to mid-rise structures, where low-rise structures have 4 or less floors and mid-rise structures have more than 4 but less than 12 floors. Sarak, 2019. The hotels and restaurants under examination have story heights ranging from 2 to 6. The main type of structural system used on these structures was the use of reinforced concrete framing, also known as moment-resisting frames or rigid frame systems. They are made entirely of freestanding columns braced by horizontal beams at each floor level. Tweet 2019. This means the columns are carrying the entire load of the building. This combination of columns and beams are designed to support horizontal and vertical loads using the rigid connections between each member of the frame, allowing them to resist lateral and overturning forces as well as allow for larger movements during earthquakes. Seismic vulnerability. This speaks to the capacity of a structure's resistance to earthquake-induced forces and displacements. Seismic vulnerability can lead to issues with the functionality and lifespan of the building. It has an influence on how buildings in earthquake zones are assessed. The level of vulnerability is affected by structural irregularities, insufficient designing, low quality materials, or inadequate maintenance. Assessments of seismic vulnerability are crucial for seismic risk management and for strengthening the built environment prior to earthquakes. Building configuration. This refers to the degree of irregularity or regularity of the building plane, i.e., the shape of the building. A regular structure is one that is symmetrical, simple, has continuous load transfer, and is not too elongated in plan or elevation views. Evaluating the building configuration allows the influence of the structure to be observed. The influence is how the building distributes the various loads and stiffnesses associated with its various load paths throughout the structure and ultimately to the ground, Gibbons 2022. For example, beams transfer roof loads to walls, floors, and columns. Columns transfer the beam loads to the foundation. Dead loads will be transferred from the roof or floor slab to the structural frame. But how they are positioned makes a difference. The greater the irregularity of a structure, the more detailed a structural analysis is required to reduce the impact of each irregularity. Building materials. Building materials are any material that can be used for construction purposes. The choice of which material to use is very important as it dictates the lifespan of the building. Materials can range from wood to concrete, steel, cement, aggregates, brick, clay, metal, etc. Now that we have an overview of what each assessment methodology entails, we will now go into the specifics of each hotel and restaurant, categorizing them as either low or mid-rise structures. Don's Hotel. This is a mid-rise 6-story reinforced concrete frame and wall building. It experienced no major damage. The picture is how it is as of 2022, not back then. D Max Restaurant. This is a low-rise 2-story reinforced concrete and wood building. It was constructed in 1968 and was a part of a complex with 2 other adjacent buildings, the Amicus Building and the Sagittarius Hotel. Sorry about that. They all collapsed completely. The Sagittarius Hotel. This is a low-rise 4-story structure with a reinforced concrete frame built in 1965. The building collapsed completely. Now, the structural system used in all 3 buildings was a reinforced concrete frame. However, the incorporation of the wood element is most likely the main cause of failure for the D-Max and Sagittarius complex. Wood has a very low mass and is not a very ductile material, and therefore its ability to withstand horizontal dynamic loads is relatively low, giving it a high level of seismic vulnerability. During the earthquake, the wood material would have undergone plastic deformation, causing it to begin cracking under the bending and tension created by the cyclic loading of the earthquake, so it would fail brittly. This assumption is made as compared to Don's Hotel, which experienced no major damage excepting for what was described by the Philippine Institute of Volcanology and Seismology 2000 as a little working on the floor joints of the south wall of the building. Don's Hotel had not only a reinforced concrete frame, but the walls of the building were also comprised of reinforced concrete, and so it stood a much better opportunity of resisting the seismic loading. The failure of the Sagittarius Hotel was most likely due to the fact that the building only comprised of a reinforced concrete frame with no other materials to assist it, creating an in-plane failure. This failure is usually due to a combination of bending and axial loads and shear forces from seismic action acting along the axis of the surface. Diala, 2013. We now move on to the Imperial Hotel, number 1. This is a low-rise, 4-story reinforced concrete building with masonry infills that was built in 1963. The building was in close proximity to 2 other structures, namely a second Imperial Hotel and the Rita Theater. The building's rear collapsed, and the first story ended up with a 38 centimeter or 15-inch offset, and both it and the Rita Theater were said to have drifted and pushed against the second Imperial Hotel. Now, the second Imperial Hotel is a mid-rise 6-story reinforced concrete frame built in 1967. The main damage experienced by this building was impact force from the first Imperial Hotel and the Rita Theater. This resulted in shear failure of the second-story columns and cracking in its other columns, infill panels, and slab. The Melbourne Hotel. This is a low-rise 3-story building with a reinforced concrete frame and masonry infilled panels built in 1970. The first story was permanently offset with its columns sustaining heavy damage, and the panels and window infills on the easterly side of the building mezzanine were pushed out and endured buckling. The structural system used in all 3 buildings was once again a reinforced concrete frame. However, the main issue with these structures was their proximity to one another. 2 buildings ended up being the downfall of the third. All the failures experienced by the second Imperial Hotel were due to impacts from the first Imperial and the Rita Theater. The rear of the first Imperial Hotel collapsed and its first story shifted. Similarly, the first story of the Melbourne Hotel was offset with its columns experiencing failure. These occurrences are most likely as a result of in-plane failures. Because of the use of infills within the frame instead of reinforcing steel for these structures, additional stiffness was added to the frame, causing it to become overstressed and attract seismic loading, inducing failure. Tweet 2019. We now have the New Society Hotel. This is a 4-story reinforced concrete frame building with shear walls and reinforced concrete slabs for its floors and roofs that was built in 1968. The building collapsed due to various factors, leaving only the frames and walls of the first floor intact. It was said that failure was primarily due to structural flaws. A column on the southeast corner of the second floor suffered torsional failure, most likely due to torsional irregularities, meaning there was eccentricity creating some distance between the center of rigidity and the resultant lateral forces at that level. In addition, adjacent walls in the location of the building also suffered out-of-plane shearing, and the northwest corner of the second floor fell into the streets. Earthquake damage to structural elements usually results in the degradation of the mechanical properties of the concrete. We now have the Sultan Hotel. This is a 5-story building that suffered collapse of the first floor with a portion of the second floor remaining intact. The second floor remaining intact, but the first floor being destroyed, sounds like it was a weak story. This means that the lateral resistance properties of the second floor were 80% greater than that of the first floor, leading to the building overturning. We now come to the end of my presentation. Thank you.